Hello again. So now let's examine the case where angle C is obtuse and see how this changes our outcome. We want to say that in some triangle ABC, if we have angle C is obtuse, then AB squared is greater than AC squared plus BC squared. So let's draw an obtuse triangle, something looking like this. And we'll label our points A, and since C is the obtuse one, this will be C and this will be B. Now again, we want to form some right triangles out of this problem, so I am going to extend the base a little bit further out, and we must drop the altitude at A to form a right angle, and we get this right angle with the altitude, and we'll call this point D. And let's use some of the Pythagorean theorem that we know. So I can get AB squared using the Pythagorean theorem. I can tell that AB squared is equal to DB squared plus AD squared. Okay, now if I can get DB and AD in terms of AC and BC and show that whatever result I get is strictly greater than, then I'll have something to work with. So one other thing that we know or we can use is the Pythagorean theorem on triangle ADC. Since now we have two right triangles, ADB, which we use to create this Pythagorean theorem, and now I'm going to use ADC to create a second one. So using ADC, we have that AC squared is equal to AD squared plus DC squared. Now, why is this so important? Well, AD squared is in my first Pythagorean theorem. So let's simplify this let's solve for AD squared in this Pythagorean theorem equation by subtracting DC squared on both sides. Then I will get the equation that AD squared is equal to AC squared minus DC squared. Well, that's interesting. So now I have something in terms of AD. Well, what can I put in terms of DB? Well, looking at the diagram, I know that DB is equivalent to DC plus CB, because DB makes up the entire side, whereas DC and CB make up the two portions. So let's take our first equation that we came up with and replace each of the terms that we know. So now we have, starting from over here, AB squared is equal to, and I'm going to substitute DB squared with DC plus CB squared. And then I'm going to substitute AD squared with what we had over here. So plus AC squared minus DC squared. Now, let's expand DC plus CB squared, and that would leave us with AB squared equals DC squared plus 2 times DC times CB plus CB squared plus AC squared minus DC squared. So that's the result I get from expanding out this binomial squared. which hopefully we still remember how to do, especially since it was in one of our more recent lessons. Now, reducing this further, we have that AB squared is equal to, well, we have DC squared over here minus DC squared over here, so they are going to cancel out. And what are we left with? Well, we have AC squared plus CB squared plus 2 times DC times CB. Now, that is what AB squared is equal to. And keep in mind, what we are trying to prove is that AB squared is greater than AC squared plus BC squared. Well, I have that AB squared is equal to AC squared plus CB squared here. So these two parts match, the one over here and the one over here. But then I have this extra portion over here, plus 2 times DC plus CB. And whatever that value is, whatever that value possibly is, it has to be a positive number. Since DC and CB are lengths of triangles and you can have a negative length. So, no matter what, since this term here is positive, and it's being added with the original value, then that is implying, all this implies that AB squared is greater than AC squared plus CB squared. Since it can't be equal to, these two things cannot be equal, because AB squared is this plus this other number here. And if you're adding an additional number onto this section, this portion, then that means that AB squared is going to be greater than those two things together. So now we have concluded that if C is an obtuse angle, then this following inequality must be true, that AB squared is greater than AC squared plus BC squared.